I'm revisiting the DS18B20 OneWire digital temperature sensor. This is the exact same original sketch I did in a previous video I will link below. Originally I just wanted to get it up and running, but now I want to see how it works in parasitic power mode, being powered by the GPIO, and I also want to see how it works when there's no external pull-up resistor being used. And that's going to require a different OneWire library. The setup is very straightforward. So I just have the OLED showing the temperature, and I'm using Arduino Uno, so it's 5 volts. Over here is where I have the DS18B20 sensor plugged in, so the sensor is just going to be out of sight, out of mind. This whole mess of wires is playing around with parasite power versus 5 volt power, external pull-up or not, and I have a potentiometer to be able to change the pull-up. So changing the pot, I have a series 4.7K resistor with the pot, and that is going between the sensor data line and VCC. So if the pot is at minimum, so it's 0 resistance, I get 4.7K pull-up. If the pot goes all the way up, it's 50K, so the maximum resistance I'll have as a pull-up is 55K, and I can check the performance as I change it. I have a jumper here that's on the sensor's VCC pin, so I can change it to either ground, and therefore it'll be in parasitic power mode, or VCC itself, and it'll run normal mode. So I'll just change that jumper as needed if I want to try going parasitic or not. And I have an oscilloscope here on the data line, so let's get the camera fixed on that. So I can use the serial monitor to see that it's actually running and reporting the temperature or not, since the OLED is off screen, but that's fine. We really only want to see what's on the scope at this point. So it's running in normal power mode, not parasitic, and it is reporting we have 23 degrees. I'm going to change that by picking up the sensor, and yes, it's getting warmer, so I'll lay it back down. It is working. So now I'm going to just zoom in on the scope and see some actual data, not just a big mess of communication activity. So I've zoomed in and I've located a spot here where we can see a couple of rising edges. This is again full power 5 volt mode, not parasitic, and the pull-up resistor is 4.7K. So these rising edges are pretty sharp and immediate. So right now I'm going to change the power jumper down to ground, and now we're going to be in parasitic mode. So up here you can see it says 85 degrees. That's when I unplugged VCC, and then when I plugged VCC into ground instead of 5 volts, I went back to having a normal temperature. So let's capture a waveform, and you can see there is now a bit of a time constant to get up to high. These rising edges are rounded, so if this is going to be our worst case when we are using parasitic power, I'm going to keep it on parasitic from now on, and if I can pass all of my tests with parasitic mode, giving us a bit of an issue on our rising edges, if it works fine in parasitic, it should definitely work in full power mode. Also, I think I'm going to change this to 12-bit resolution. We can go from 9 to 12, and that will give me the most power-hungry use of this. I'm going to re-upload. So we've uploaded the code and we are still running. I'm going to capture a new waveform, and it looks about the same. But the other part of this experiment is, can we get this to work with no 4.7K external pull-up? Over here at josh.com, there's a whole investigation on this back in June 2014. And I will just make reference to this down in the description, so you can go check it out yourself. This is an experiment where they're wondering, can you get rid of this resistor? And he changed the code after going through some investigating of the data sheets and the timings and the pull-up resistor on the Arduino. The feasibility study said, hey, it should be good. So he did some testing and modified the OneWire library and says it worked. And there's some questions here. How can there be enough current through a 50K internal pull-up on the Arduino to give parasite power? He says the DS18B20 will only draw 5 microamps when idle, and when you're doing a temperature conversion or an E² prom write, you need 1.5 milliamps but the OneWire library is actively driving the bus high when this is happening. So if the GPIO can give you like 20 milliamps or so, then when you're doing these high power required operations, you've got more than 1.5 milliamps available. You're not relying on this 50K pull-up. So all of this is basically saying if you modify the OneWire library to use an internal pull-up instead of the external 4.7K, it'll be up to 50K maximum on the Arduino, and even then it should work. I believe it calculates out that at 5 volts, a 50K pull-up will give you 100 microamps, and you only need 5 when idle, and when you're not idle, you're being given up to 20 on the GPIO with a hard logic high output. So it should work. And long story short, here's the GitHub modified OneWire library called OneWire No Resistor. You have to install this manually by downloading the zip file and either importing it through the library manager as a zip file or putting it in yourself manually, but it still has the name OneWire. Just like the original library, it's called OneWire, so it's not a separate library. It's kind of written to overwrite the original, and I don't want to overwrite the original, so I'm just going to play around with this informally. For one thing, the main normal OneWire library is recently updated this year, 8 months ago, but this other one for the No Resistor, it was done in 2014, and I do see as I'm glancing through there are differences in this code from the current OneWire version. So I'm just going to experiment with this temporarily, and for now, just looking at the code, this isn't the only line changed, but here's what's going on. He's added in or tweaked the code in a few places to enable the internal pull-up, which is normally not enabled. So he's saying he's going to not use the external 4.7K, he's just going to rely on the Arduino pull-up. So before I do this, since I already have my own code working with this regular OneWire library, and I do have an external pull-up with a pot that I can do between 4.7K and 54.7K. First, I'm going to try that before I even bother changing the library, because that should be a proof of concept. If an external 50K pull-up works, an internal should as well. The Atmel Arduino's Atmega 328 datasheet says if you're running at 5 volts, then you fall within the range of VCC is between 2.4 and 5.5. You need 0.6 times VCC to guarantee seeing a logic high. So 0.6 times 5 volts is 3 volts. If we can get at least 3 volts on our OneWire bus when we expect a logic high, we should be guaranteed to see a logic high. Pull-up resistance on the I/O pins. Minimum, you're going to have at least 20K, and the maximum to expect is a 50K pull-up. So with my external setup, I have 54.7K, so I should be able to simulate having an internal pull-up. So I'd like to try experimenting with this pull-up resistance. I'm still not using the modified OneWire library using internal pull-ups. I'm just modifying my external pull-up with a potentiometer, but I did change the normal OneWire library. So here's the normal OneWire.cpp file from down in Arduino's library folders. I made some comments here, and this is only meant to be a temporary modification just for right now, but I will put this on GitHub and link it below just cause. So what I'm doing, I added this switch here called OneWire pin 3 debug. So I defined that OneWire pin 3 debug is true right now. I want to generate a test output that I can use to trigger the scope at the right place. So here, when we initialize the OneWire library, it'll come in here, and if I have defined I want pin 3 to be a debug, I'm going to turn pin 3 into an output, and I'm going to initialize it low, because I'm going to generate a logic high pulse to trigger the scope. If I have this original definition commented out, then this is just not going to be paid attention to because it hasn't been defined. Then down here where the master or Arduino is going to read, this is where the pull-up resistance comes into play. The Arduino master is about to read the bus and see what the sensor is doing, setting it high or low. So right here, the master sets the bus as an input and it lets it go floating, so the resistor is going to kick in. So I've added, at this point, I want to generate my oscilloscope trigger pulse because this is the beginning of an RC timing circuit. The capacitance of the Arduino pin and the temperature sensor and the wiring, along with the pull-up resistance, it's going to cause this signal to gradually rise to a high. So I'm going to start the scope trigger. They are waiting 10 microseconds to allow the pin to stabilize if it's trying to go high, and then they want to do an actual reading. So at that point, I'm setting my test trigger back to low because by now they are ready to read that pin. I know that my data line, if it's trying to be a high signal, it has to be at least 3 volts to be guaranteed read as a high. So that's it. That's all I've changed, and it's all turned on or off in the code based on if I have defined pin 3 as a debug. So now I've zoomed out again to show all of these channel 1 yellow trace positive edges here. That's when data is being read by the Arduino master, and the sensor is going to either drive it low or let the pull-up bring it high. So let's zoom in. Everything begins right here on this data falling edge. Back in the OneWire code for reading, right here the data line is set as output, it's written low, and then 3 microseconds pass and it becomes an input and the resistor starts pulling it up. That's the 3 microsecond area right here, and so generally somewhere over here when this test trigger goes low, the master is about to read this data line and it looks like it was trying to be a high signal. So it's got lots of time before right here it's got to be guaranteed high, and it is. And this is with the 4.7K external pull-up. And I'm just going to set this external pull-up all the way to 54K. I'll clear this serial monitor so we can see it's actually still running. With 54.7K external pull-up, what we want to know is, did we make it up to at least 3 volts to get a guaranteed high? I added voltage readouts here for the sensor data and the GPIO for my test trigger signal. The sensor data, I've moved the pot back so it's 4.7K ideal pull-up. So we have 5.07 volts. And since we're measuring now with the pot at maximum resistance, 50 plus K, I'll re-trigger. So our maximum on the data line is really only 4.62 volts on this reading by the time it gets as high as it looks like it's going to get. So already we're working with less headroom. But this is our worst case pull-up, so again, here is when we're going to read a logic high. So how high did we get? Did we get 3 volts or more? I've put a cursor now, one on the trigger when it's just about to go low, and another cursor on the data voltage at the same point in time. And the voltage on channel B is 3.92 when the master is about to read and see if it's high or low. So if it's got to be at least 3, we've met that condition. It's 3.9 and the system is working. So this suggests if we use Arduino and an internal pull-up, worst case, this is going to be about the behavior we get and it should work. If we are about to go with the code that uses no external pull-up, let's just remove it right now on the existing code and show that it does not work if there is no pull-up at all, internal or external. Alright, I took out the 4.7K series resistor, so the pot is also out of circuit. Obviously, when we are ready to read data, there's nothing to pull it high. So now I renamed my Arduino library OneWire folder to just some backup, and I downloaded out of GitHub this OneWire No Resistor code because it has the same OneWire file names. I just put these in the OneWire folder where this normal one resides. So I overwrote the header and CPP files. I know this sounds confusing. So then I opened up the OneWire.cpp, which came from the No Resistor version of it, and I added in the exact same debug pin 3 changes I made on the regular OneWire.cpp file, and down where it's time to read the bus. This No Resistor code has those changes to give an internal pull-up, and I'm generating my test signal to trigger on all of this to see how does this look. So I just did a fresh start, and using this code with an internal pull-up, I have no pull-ups outside. It's working. And here's a screen capture triggering on this internal pull-up in the Arduino. So this is a lot better than a 50K. Right here is when we are going to read a logic high, and we are definitely up there on the high. So it is possible to make this sensor work with modified code to use the internal resistor, and this waveform is using full 5-volt power. Let me put it in parasitic power. Wait a minute, 85 degrees. Is this not working? I even tried setting this temperature resolution to only 9 bits instead of 12 to try and use less power. My waveform looks okay. I have rather sharp rise times and my maximum is 4.63, so I'm not sure what's happening. I'll put it back to plain 5-volt straight power, and now I'm getting my readings again. And if I refresh this capture, and my maximum is 4.7, when it's time to read a high, we're definitely up there. Back to parasite power, not working. And there's a zoomed in trace on parasite power again. When it's time to read a logic high, we're pretty much good. So I'm not sure what's happening with that. And again, this code is 4 years old. It does look like there have been revisions in the main OneWire library. So from Josh's page, it looks like it should work on parasitic power. He even uses 2 GPIOs to drive the low. He doesn't even put it on regular ground. So I don't know why mine doesn't work. It has been over 4 years, and maybe the other Dallas Semiconductor library has changed in some way that affects everything. Well, my camera died and then my audio recording died, so I'll just summarize. I went to the GitHub location for the No Resistor version of the OneWire library, and there is an example sketch in there to test it out with No Resistor, and that uses parasitic power. The data is pin 9, and then pins 10 and 8 are set as outputs driven low to give ground, and therefore the sensor wires can plug straight into pins 8, 9, 10 and have the power pins grounded and the data going to 9. And I tried that, and it worked. I was able to read the temperature. And I looked at the captures on the scope, and of course, they looked okay. So I don't know why the captures on the scope also looked okay on my sketch, but in parasite mode, I cannot get the sensor to run despite the data looking good. So there's some weird nuance, but really it doesn't matter. The original library modification and that corresponding sketch are both from another era for something years ago, and I know there's been changes in the library, and my sketch is based on having it working with the current modern library, so trying to hack them together, maybe there's just some stupid thing, but I guess the overall thing here is it does work and it can be made to work, so it's an interesting investigation. I would only probably trust it on the workbench. It's good to know that it can work. Using the internal pull-ups allows enough time for data to be valid, even if the internal pull-up is 50K.